In the previous lectures, we worked on converting uppercase characters to lowercase characters. But there's more interesting things that we can do. One example is encryption. Suppose I want to encrypt a file so that other people can't read it. I'm going to show you an example of a simple encryption mechanism that was used 2,000 years ago by the Romans. Let's copy lower1.c to rot13.c. The reason for this name, rot13.c, will become clear as I write the code. Okay, let's edit the file. Okay. We're going to use the same structure of the program as we did before. One difference is going to be here, the following. If we have uppercase characters, what we want to do is add, in essence, 13 to every single character with wraparound, so that the A will be converted somewhere in the middle of the alphabet, and the middle of the alphabet will be converted to the end of the alphabet. And the way we do this is, again, by using character arithmetic. We also need the following. This is the mod operator, mod 26. So what's going on here? Suppose our character is actually the A. Then A minus A is 0. 0 plus 13 is 13. 13 mod 26 is 13. And that places us in the middle of the alphabet. Okay, if we're at the middle of the alphabet, then we're going to have some value, character minus A is going to be roughly 12, 13, and we add 13, and we get a value around 25, and that's at the end of the alphabet, and that's exactly what we want to do. We're adding 13 to each character with wraparound, but we don't want to do it just for the uppercase characters, we want to do it for the lowercase characters. So we do the following. We have lowercase characters. Perform a similar operation. If we don't have an uppercase or lowercase character, but it's some other printable character, we merely want to print it back out. So we're not going to be encrypting other character types. Alright, let's see if this code compiles. Yes, it does. Let's see it in action. Let's actually encrypt this piece of code. And that's quite reasonable. Uppercase and lowercase characters are separately encrypted, while non-uppercase and non-lowercase characters, including white space and new lines, are preserved. Now what's interesting is we can actually apply this twice. What happens if we apply this twice? We've rotated everything 13 characters to the right, but we have 26 characters in the alphabet. If we rotate that twice, we should actually come back to where we were before. So what I'm going to do now is save this in a temporary file, as you can see, and now we're going to encrypt again, and that gives us the original code. This makes sense. Now I'm also going to introduce you to another interesting facet of Linux, and it's called a pipe. If I sit there and cat rotate 13.c, which displays things to the screen. Okay, suppose I do this, and I want to send that to the encryption algorithm. Then I type this vertical bar symbol. That's called a pipe in Linux, and what it does is it takes a standard output from the cat program and redirects it to the standard input of the executable. So if I do this, what I'm doing is I'm sending the file to the encryption algorithm, and it's being encrypted. But I can do this again. If I send the standard output to the standard input of a.out again, I'm doing this twice, we get the original code, and that's precisely what we'd expect. Okay, so we've learned a few things in here. We've learned an old Roman 2,000-year-old algorithm. We've done a little bit more with character arithmetic, and we've learned a very important part of Linux called pipes. And again, a pipe, what it does is it merges standard output of one program to the standard input of another program. And that concludes this lecture.